Hello everyone, we are team NetraX and our project is DrishtiGuard. Our solution addresses the problem of zero trust security and verifiable device passport for campus IoT. DrishtiGuard is a Raspberry Pi based IoT security gateway designed to provide a security layer between connected IoT devices and the network. This is what we have in our first page. Then moving on to the next page of our slide. The core problem is that an IoT device may be trusted after its initial onboarding, but if that device is later compromised, it can potentially be used for lateral movement, service abuse, or a data exposure. DrishtiGuard addresses this by placing a Raspberry Pi security gateway between IoT device and the services they communicate with. Our proposed architecture consists of 5 core security capabilities. They are continuous authentication to repeatedly verify device identifier, least privilege communication to control unnecessary communication, anomalous behavior detection to identify deviations from normal behavior, verifiable device passport to maintain important device security information, and selective isolation to contain malicious connections while preserving essential services. Then we have, this is the first capability we have implemented in our current working prototype. So now we will be moving on to our live prototype, where let us now demonstrate our current hardware prototype. The Raspberry Pi is acting as our security gateway with the connected IoT device being authenticated through it. First, we initiate the authentication process, and for the preference I would be adding a screenshot of the authentication process on the screen. Now the gateway verifies the identifier of the device, and once the verification succeeds, the device is authenticated. But the important part of our implementation is that we do not permanently trust the device after this first authentication. Our prototype performs the authentication process again every 30 seconds. Now, so after the initial successful authentication, the system waits for the 30 seconds, then 30-second interval, and performs the next verification. Here we can see that the next authentication cycle taking place successfully, the same process continues periodically. So the device is continuously revisited and re-verified instead of being trusted indefinitely. In simple terms, our current prototype works on authentication, then 30 seconds of break time, then re-authenticate, 30 seconds of break time, then again re-authenticate. Then we have our page 3. Moving on to that, the technical architecture. Now IoT devices generate network traffic which passes through the Raspberry Pi security gateway. The proposed architecture then moves through processing, design, and policy enforcement before allowing or isolating traffic, with alerts and visibility provided through the management layer. Our hardware platform is a Raspberry Pi based gateway running Linux, specifically Debian 13. At the current prototype stage, we have demonstrated the authentication component, which is the first step in this larger security workflow. Then this is what we have in a third page. Then moving on to the fourth slide, the solution is feasible because the Raspberry Pi provides a compact platform that can operate as a security gateway, while its Linux environment supports the requirement network level configuration. Our main challenges are maintaining a reliable gateway operation, handling multiple connected devices, and ensuring that future security control do not disrupt essential communication. We are addressing this incrementally, starting with the continuous authentication layer and validating each component before extending the system. Then that is what we have in a fourth page. Then moving on to the fifth and sixth are research and some closing pages and impacts and benefits. Thank you so much.